Hi everyone. In this video, I will show you how to do statistical analyses in Excel. First, the most important thing you need to know about doing statistical analysis in some sort of software package that is doing it not by hand but on a computer is that it can sometimes be really frustrating, and that's okay. I encourage you to embrace the frustration, embrace how annoying it can be sometimes when things don't go the way they're supposed to, and really approach it with a lot of humor, approach it with a lot of patience, and approach it with the desire to problem solve and troubleshoot and just roll with the punches and make it work. Okay, before I show you how to do some of these analyses in Excel, a couple of technical issues. So first, all Warren Wilson students have free access to download Microsoft Excel and other Microsoft software onto your personal computer. If you need help on how to do this, you can see some helpful tips that are located in Moodle or talk to your instructor. The other thing you need to know, number 2, is that what you need is the downloaded version of Excel onto your laptop. There are other versions of Excel, such as an online version that you also have access to, or you could download it on a tablet and so on. But those other versions, they don't have the capability that the downloaded version has when it's on your laptop. So you really need that version. Alternatively, you can use Warren Wilson computers that have it already downloaded on those machines. Okay, and the third thing you need to know is that even if you downloaded Excel onto your personal laptop, different people's versions will differ from one another. And part of that is based on when you downloaded it and what kind of computer you have. I'm going to show you what it looks like from my end on my machine, which is a PC. People that use Macs in particular will find that things are pretty different. So this video should still be helpful for you, but know that things are going to be a little bit different on a Mac. And I really encourage you to just troubleshoot and figure things out, and maybe even get together with other students in this class who also have Macs so that you can do that problem solving more efficiently. And for everyone who's using Excel for the first time, just know again that sometimes things don't go according to plan, and that's okay. Part of the game for everyone is troubleshooting and problem solving, and I encourage you to use Google and YouTube and find other useful tips wherever you can. Okay, so now let's get started. So I'm going to open up Excel. And I've enlarged it a little bit so that things look more clear in the video. Okay, so the most important thing to know is about this whole central area. It's a grid, right? And each column has a label with a letter. So all of the columns are identified by a letter, A, B, C, etc., while all of the rows are labeled by numbers. And so if I just click into any random cell, these are called cells, you know its name. Its name for this one is G, column G, row 6. So this is G6, okay? And this is A1, and this is D1. So what do we need to do? Step number 1, we got to input your data, all right? I'm going to use the same experiment that I talked about in a previous video about doing the stats by hand. So here we're testing hypothetically whether fertilizer produces more yield in tomatoes because it's tomato season and I love the tomatoes. So I have 2 treatment groups in this hypothetical experiment. One is the experimental group and the other is the control group. So just type that in. It doesn't have to be an A1 and B1. It could be anywhere but this just makes it easy. And then if you want, go ahead and you can highlight a whole column, move that over to make those columns wider, however you want. And now under these labels, we're going to input the data. That is for what do we do in this experiment? For each tomato plant, right? Half of them under experimental conditions, the other half under control conditions. In this case, why don't we go ahead and make these labels a little more descriptive or more useful. We'll call this fertilizer and no fertilizer. And what did we do? For each plant in these two groups, we weighed all of the fruits that it produced in a season. And we did that, say, in pounds per plant. Okay, so we want to include those units, pounds per plant. And now what are we going to do? We're going to list every single plant and how many pounds per plant of tomatoes did that plant produce. Now, I am going to actually make these a little shorter, wrap the text, center it, underscore. Nice. Okay, looking good. And I'm just going to make up some numbers. Okay, how many pounds? 1.3, 3.5, whatever. Okay, and I'm going to make up some numbers here, right? Just you're never going to make up numbers. You're going to use real data. And after you've entered your data, make sure to look over those data. Make sure that that's correct, because everything we're going to do from here on out is going to use that data. So crap in, crap out. If you put in the bad data, you get bad results. That is inaccurate data results in inaccurate results. Okay, so just proofread that. All right, so that's step one, is we are entering our data. Step two is let's organize another table. And this one is going to be for all of those statistics that we are trying to calculate. So what kind of statistics are we trying to calculate? Well, we're going to calculate the mean, variance, standard deviation, range, t-value, and p-value. And we're going to do that for two treatments, the fertilizer treatment and the no fertilizer treatment. And just to make it nice and neat and clear, I'm going to put some borders around it. And I'm going to center those titles, labels, I should say, headings. You don't have to do that. It's just, I like to do that. What else do we need to do? Well, if we want to be really precise, let's include units. The mean, what are the units? The units are always the same as the data. So it's going to be how many pounds per plant. You can use this wrap text function to make those fit neatly. The variance is so funny. The variance is in the units of the data, but then squared. Could you believe that? So for now, I'm just going to use this abbreviation. Again, I'm going to make that a little more legible. Standard deviation is in the same units as the data. And so is the range, pounds per plant. It's nice to do the labeling so that you can really keep things straight. What's what are the units? Also, when we get to the t-value, I'm going to merge these two cells. All of that means is you're taking the two cells, sticking them together, because there's not going to be two different t-values, one for each treatment group. There's only going to be one t-value. And the same thing goes for the p-value. Okay, now I'm going to just move that over here so that we can go ahead and see everything a bit more clearly. All right, that looks great. So That's step 2. We're just going to organize what kind of statistics we want to calculate, make a neat table just to help us keep track of what all the different numbers mean. And now within each of these cells, for example, in E2, that's what's the mean for the fertilizer treatment group. Now what we get to do is tell Excel to please calculate stuff for us. And that's really what the strength of Excel is that not only is it nice for organizing your data, but it's particularly nice for calculating things quickly for us. For example, I could type in the symbol equals, which is our way of telling Excel that we wanted to calculate something. And then I could have 1 plus 3. And when I press enter, it'll provide the answer for us, which is that 1 plus 3 is equal to 4. What's even niftier than just giving equations that are numerical is to give it an equation with some coded language. So for example, when we want to calculate the mean of the fertilizer treatment group, we're going to start for every equation always with the equal sign. And then we're going to tell Excel what it is we wanted to calculate. And in this case, we wanted to calculate the mean. Now, the code in Excel for the mean is the word average in all capital letters. So far, this formula is saying, hey, Excel, calculate something. Calculate what? The average. The average of what? And that's why you need to put in a parentheses. And then you need to tell it not every single number necessarily, but tell it where the data are located that need to be averaged. And in this case, they are located in A2. Oops, I typed in A1, just backspace, delete that. It's A2 because A1 is just our label. And notice that when I typed in A2, Excel went ahead and highlighted that cell. And that way you can keep track that you are indeed highlighting or selecting the cells that you want. Now, we don't only want the average of A2. What we want is the average of all those numbers in the fertilizer treatment group. And the way we tell Excel to do that is to use a colon. And then we're saying go all the way from A2 all the way to A9. Oh, that's a bit too far, so delete that, A8. Then you have to close the parentheses and press enter. There you go. Just like that, it calculated the average for the fertilizer group. So we'll do the same for the no fertilizer group, equals average. And this time, rather than typing in A2 to colon A9, instead you can use the mouse to click and hold one of the cells and keep your button pressed, and then you can drag to select all of the data that you want. Then you lift up your finger and close the parentheses. So that's just a second way of selecting the data. You can type in the code or you can just highlight it with your cursor. Press enter. No worries. Now, I hope what you noticed here is like, oh my goodness, the fertilizer average was 2.8 pounds of tomatoes per plant. Meanwhile, the no fertilizer group had a whopping 18 average pounds per plant. That sounds like a lot, right? So before you move on and do all your calculations, go ahead and look at the calculations that Excel produced and think through whether they make sense or not. Because this 18 should strike a bit of a red flag for you and make you think, maybe I had a typo somewhere, right? And indeed, you may have already noticed this earlier, but yes, I had a typo, okay? And so I'm going to correct this typo. It's not 111 pounds. It was actually 1.1 pounds. So I'm correcting the data, and notice what's going to happen to the average, the mean, when I press enter. Here we go. Once you change data in your original table, Excel updates automatically the calculation, okay? So that's a really nifty thing about Excel. All right, let's move on. What about variance? What's the variance of the fertilizer group? That equation is going to be equals VAR, parentheses, data, close parentheses, enter. And for the other group, equals VAR, parentheses, select the data, close parentheses, enter. Standard deviation equals STDEV. Let me pause there for a second. Notice that whenever you start typing in a formula, an equation, Excel is going to give you a bunch of different options. All of those different ways of calculating standard deviation, they have their place, right? But for the purposes of our class, please just follow the formulas that I'm providing for you here, okay? So STDEV, parentheses, select your data, close parentheses, enter. What about the range? The range is just the highest number in a group minus the lowest number in the group, right? It's saying what is the difference between the highest and the lowest numbers. So the way we can tell Excel to calculate that is equals max. This asks Excel to find the largest number out of all the data points, and then we're going to subtract min, the lowest number of all the data points. That's the average. Oh, excuse me, that's the range. And we're going to do the same thing for the other treatment group. Now, what have we done? We have calculated the mean, variance, standard deviation, and range. Those are our descriptive statistics. But the real fundamental core of our experiment is not just to describe what's happening in these two treatment groups, but to ask whether they are statistically similar or different. For that, we need to calculate the t-value and the p-value. To calculate the t-value, you can do this by hand. You can write your own formulas in Excel. Hold on 1 second while I shut my window. Sorry about that. Okay, so we need to calculate our t-value and our p-value. And like I said, you can calculate your t-value in a number of ways, but the easiest by far is to use the t-value calculator. You can find this located in Moodle, or if you can't, ask your instructor. What I've done here is created a way for you to just input your data, and then the calculator will find the t-value for you. If you want, I have divvied up each of these steps with an explanation next to each step so that you know what Excel is doing. And you can follow along with this formula. All you need to do to get your t-value is, oops, I'm going to go back to my original data. Here we go. Is copy, right? You want to select your data table, copy it, and then paste it right here. If you want to see that a little larger. And there you go. Hopefully what you saw is that all of these steps populated automatically. And that's because I'm going to click into step 1 and show you right here up high that I had put in the formula already there. So that all you needed to do was put in your numbers, and then Excel used the formulas that are already in there to calculate each step for you. And all you need is to go down to step number 5, and there you go. That's your t-value, 0.58 in this example, 0.58. Now we can use that t-value and degrees of freedom with one of those t-tables. But more precisely is we can calculate the p-value right here in Excel. And to do that, we use the code equals t-test, parentheses, select the data for one of your groups, comma, select the data for the other group, comma, number 2, comma, number 2, close parentheses. Those two number 2s, they are there as additional code telling Excel exactly what kind of t-test to do. Because it turns out that there's actually different types of t-tests, and you want it to do this specific one. And then press enter. And there you go. That is your p-value. You notice here that there's quite a lot of significant figures. Please use logic when reporting your significant figures. Do you really need that many? Most likely you don't. And so here are two buttons that are really useful. One of these buttons is going to give you more sig figs on the number. The other is going to give you fewer. So in this case, I suggest that 2 is plenty. So our p-value is 0.57. Well, I hope that was helpful. In our next video, I'll show you how to make really accurate and really professional graphs in Excel. Bye.